Okay, here we go for example 2. This one says we have a triangle ABC drawn so that the points D and E are on the sides AB and CB respectively, such that the line segment DE is parallel to the line segment AC. And when lines are parallel, then certain angle relationships now have to be true, like these corresponding angles C and E, they have to be congruent to each other. These angles A and EDB have to be congruent to each other. And therefore, when I have something like this set up where it says, if EB is 3 more than DB, segment AB, so from A to B is 14, and C to B, that's this part right here, C to B is 21. We want to find the length from A to D. Well, first, let me go back to this part. The length from E to B is 3 more than DB. So I'm going to call the DB X. That means if EB is 3 more than that, then this is going to be X plus 3. Now, I want to know what this length is right there. And that length is going to be the difference when the whole thing's 14. If I knew what this value of X was, then I could find what this is because these two things have to add up to 14. So I'm going to look at this and say, well, I can see that I have this triangle right here, ABC, and I can see that I have this triangle right here, where I already have two pairs of angles that are congruent. And then, of course, this angle is an overlapping angle. So here's another example of the reflexive property when the angle is congruent to itself. So all three angles of my green triangle are congruent to the corresponding angles in the red triangle. And therefore, these triangles must be similar to each other. If any, whenever you see these line segments that are parallel and not congruent, that means that these triangles must be similar to each other. But let me go ahead and set up an equation now. So since I know, I'm going to start by calling the first triangle ABC. ABC is a triangle that's red. That's similar to my green triangle because all the angles are congruent. So ABC corresponds to the triangle named DBE. It's very important that we name our triangles with our corresponding points because otherwise what happens after this is going to be all thrown off. So this again is the geometry portion. This is where you got to be very careful when you list what points have to correspond. And now I can say, well, I know that the side AB of my red triangle corresponds to side DB of the green, and BC of the red triangle corresponds to BE of the green, and finally AC of the red triangle corresponds to DE of the green. So there's all three. Now, of those three ratios, again, there's one of them that I just don't need because I only need two of them to write my equation and solve. I don't need all three. And since, again, I have the side AC and DE that I don't know and don't want to know, then that's the one I'm going to get rid of. Find the one that you don't know, you don't want to know, get rid of that one. Now I'll go ahead and substitute. What's the length from A to B? They tell me it's 14. What's the length from D to B? I've called it X. What's the length from B to C? They told me it was 21. And what's the length from B to E? I called it X plus 3. So then go ahead and solve for X. Tell me what you find. See, I found X was 6. And now I got to go back again and read because I want to know what is the length of segment AD. Well, X, I know now, is 6. That means that if the whole segment from A to B is 14 and that's 6, that means this part right here has to be 8 because 6 plus 8 makes 14. So the length from A to D is 8. And that's the answer to my question.